Hello, this is Mr. Civil. Please welcome to my YouTube channel. If you have not yet subscribed my channel, please subscribe and don't forget to press the notification button to get all my latest videos. In today's tutorial, I'll show you on how to adjust coordinates using Bodwitch'S method. So we have a question that says the table below shows values reduced from a traverse observation. Compute final coordinates of a point of points P1, P2, P3, P4. Given point T is 9372.98 meters north and 3854.28 meters east. Use Bodwitch'S method to adjust the coordinates. So we can have a look at the table. Line TP1 has a distance of 155 and a bearing of 100 degrees 15 minutes and 20 seconds. Line P1 P2 has a distance of 200 meters, a bearing of 40 degrees 41 minutes and 20 seconds. Line P2 P3 has a distance of 249 meters, a bearing of 10 degrees 15 minutes and 20 seconds. Line P3 P4 has a distance of 190 meters, a bearing of 285 degrees 57 minutes and 20 seconds. Line P4 T has a distance of 45.4 meters and a bearing of 198 degrees 56 minutes and 30 seconds. So let's go to solution straight away. So first of all, we shall calculate the reduced bearing. So we know that we were given the bearing of line T P1 as 100 degrees 15 minutes and 20 seconds. So if you want to calculate the reduced bearing, you can see that we have north, east, south and west. So 100 degrees 15 minutes and 20 seconds, it falls on the second quadrant. So you can see that here the second quadrant, when you want to get the reduced bearing, it's 180 degrees minus the bearing. So I've done it 180 degrees minus our bearing, which was 100 degrees 15 minutes and 20 seconds. So I got my reduced bearing as 79 degrees 44 minutes and 40 seconds. We shall do same to line P1 P2. So we are given that it had a bearing of 40 degrees 41 minutes and 20 seconds. So that it falls in our first quadrant over here. So you can see that the first quadrant has no change. So our reduced bearing will remain same. That is 40 degrees 41 minutes and 20 seconds. Line P2 P3, we are given the bearing as 10 degrees 15 minutes and 20 seconds. So it falls in the first quadrant. So we shall have no change. It will remain the same. Line P3 P4, we are given a bearing of 285 degrees 57 minutes and 20 seconds. So this, it falls in the fourth quadrant. So you can see that the fourth quadrant, if you want to get the reduced bearing, you take 360 degrees minus the bearing. So I've done it over here. I took 360 minus our bearing. So I got my reduced bearing as 74 degrees 2 minutes and 40 seconds. For line P4T, we are given our bearing as 198 degrees 56 minutes and 30 seconds. So it falls in the third quadrant. So the third quadrant says that you take the bearing minus 180 degrees to get our reduced bearing. So I took the bearing and then I subtracted 180 degrees from it. So I got my reduced bearing as 18 degrees 56 minutes and 30 seconds. So that is how we get the reduced bearing. So you can see I filled a table which has line, distance, the bearing, and the reduced bearing which we have just calculated, the quadrants, the latitudes, and the departure. So this information we are given up to here, up to bearing. So I calculated the reduced bearing. So when you want to know the quadrant that it falls, you look on the bearing. So we have a bearing of 100 degrees, so it falls in the second quadrant. You can see it over here. So the second quadrant is southeast, so I have named it here southeast. And then 40 degrees, the 41 minutes and 20 seconds, it will fall in the northeast quadrant. Also the 10 degree will fall in northeast quadrant. 285 degrees will fall in the northwest quadrant. And then the 198 degrees will fall on southwest quadrant. So when you are filling the table of quadrants, you use the bearing, but you don't use the reduced bearing. So this reduced bearing will just help us to find our latitudes and departure. So I'll show you on how to calculate the latitudes and departure first of all. So I've done it over here. So when you are calculating latitudes, its formula is L cos theta, where L is our distance and theta is the reduced bearing. So for line TP1, our distance was 155 meters, and then I have multiplied by cos theta, that is the reduced bearing, which is 59 degrees 44 minutes and 40 seconds. So I got it as 27.598. So that is the latitude of line TP1. Also for line P1, P2, I took the distance which was 200, and then I've multiplied by cos. So cos theta, which is the reduced bearing, that is 40 degrees 41 minutes and 20 seconds, and then I got it as 151.652. So you can calculate the rest of them, but me, I have already calculated, I have mine. So you can see that the latitude of line P2, P3 is 245.022. The latitude of line P3, P4 is 52.229. The latitude of P4T is 421.281. So I have filled my table, and then departure you will take L sin theta, where L is the distance and theta is the reduced bearing. So for the first line TP1, our distance was 155 sin the reduced bearing, which is 79 degrees 49 minutes and 40 seconds. So I got it as 152.524. And for the line P1, P2, I've done it over here. 200 times sine the reduced bearing, which is 40 degrees 41 minutes and 20 seconds. So I got it as 130.390. So I have filled my table over here. So you'll calculate the rest of them. For me, I've already calculated. So the next line was P2, P3, which has 44.332. The next one, 182.680. That was line P3, P4, and then the departure of line P4T is 144.579. So I'll show you why I've put a negative here, a positive here. So let's draw. So this is our north, our south, our east, and our west. So our north is positive because it's on the upper side. Also this one is positive. Then our south is negative and our west is also negative. So when you see the quadrant is southeast, so our latitude will put a minus because of this. Our south is minus, so we shall put a minus, and then east is positive, so we shall put a plus over there. So the same you do for all of the quadrants. So this one is northeast, north is positive and east is positive also. So I've placed a plus and a plus. Also for the next one, northeast, so a positive and a positive. The next quadrant was northwest, so our north is positive and our west is negative. So that is why I've put these signs over here. And then when you do the summation of the latitudes, you get that it is 0.026. This is positive. And then this one is our departure. The summation is negative 0.013. So we can see that these are the errors that we have. Also, I have calculated my perimeter over here. So I have added all the distances to get my perimeter, which is 1239.4. So these are our adjusted coordinates. We have a column of points, northings and eastings. So I'll show you on how to calculate the coordinates of P1, P2, P3 and the others. So we are given that point T had a northing of 9372.98 and a easting of 3854.28. So let's start with the northing. So I'll take 9372.98 and then I'll add, so this is minus, so I'll minus 27.596 minus 27.596. So I've got 9345.384. So this one I'll fill here 9345.38. So the northings of the next point, that is P2, I'll add 151.652. So I'll just say answer plus 151. So you have to take this and then you add this, so you get P2. 151.652. So I'm getting as 97.04. So the next one I'll do the same. Answer plus. So our answer was this one, so I'll add 245.022 plus 245.022. I'm getting at 9742.58. Then point P4, I'll take the answer and then add 52.229. So I'm getting as 9794.29. and then the coordinates of T, because this was our closed traverse, you can see that we have point T and point T at the downwards. So now I'll minus for 421.281 minus, because of this sign over here, minus 7 minus 421.281. I'm getting as 93.006. So you can see that our T here and T here differs, so it means that we have an error. And then these things I'll do the same, so let me do quickly. 3854.28, this was the easting that we were given in the question, so I'll add 152.524 to get my P1 as 406, 4006.80. Then I'll add here 130.390. I'm getting 4137.19. Then when I take this one and then I add answer plus 44.332, I'm getting 4181.526. Then when I minus 182.680, I'm getting 399.85. So you don't worry about this one, you can see on the calculator. And then now I minus this one, 144.579. I'm getting 3854.27. So this one you can see also it has an error. So now we shall go and correct the errors using the Bodwitch'S method. So I have done it over here. So this is the correction using the Bodwitch'S method. So the formula is distance over the perimeter times the error in latitude or departure. So let's start with latitudes. So line TP1 had a distance of 155, and then I showed you that it had a perimeter of 1239.4, and then be careful now, I've multiplied by negative 0.026. So this one was our error. You have noticed that the error here is positive for the latitudes. So in the correction, I'll use as negative. And when the error is negative, in the correction you use positive for you to get a zero error. So for the line TP1, I got my answer as negative 0.002325. Line TP1, the distance was 200, and then the perimeter is the same, 1239.4 times negative 26. So I'm getting the error, the correction as 0.00420. You have to do same for all the others. So I've already calculated mine. You can do the same. So line P2, P3 I got as 0.00525. Then line P3, P4 I got as 0.00399. So I have calculated all my corrections for the latitudes and the departure. So departure I'll do the same. Departure I had an error of negative 0.013. So now I'll use here as positive. So you can see that I've taken the distance divided by the perimeter times 0.013, and then I got it as 0.00163. So you can have a look at it. That was the corrections on the departure. So now let us look on the corrected latitudes. You can see that we have latitudes. This one was the first one, line TP1 was negative 27.596. So I'll take that and then I'll minus, because our the correction was negative 0.00325. So I've taken it and then I got it as negative 27.599. The same I'll do for line P1, P2. The latitude was 151.652. So I took that and then I took the correction, which was 0.00420, which is this one. And then when I subtracted, I got my answer as positive 151.648. So you can calculate for the other lines I've showed you. Also the departure, we shall do the same. So we had a departure of line TP1 as positive 152.524. I've taken it here and then I have added, because the correction was positive 0.00163. You can see it over here. Then the answer I'll get as positive 152.526. So for the second line, the departure I calculated, I got it as 130.390. And then I'll add the correction, which is 0.00210. This one, the correction of line P1, P2. So I've done same for all the other lines. Don't worry, you'll get the PDF in the description. So I have my corrected latitudes and corrected departures. So I'll now tabulate my data. So I have tabulated my data. So these are the corrected latitudes and departure. You can see for line TP1, latitude I have minus 27.599 and the departure 152.526. For line P1, P2, I have a latitude of positive 151.648 and a departure of positive 130.392. Line P2, P3, I have a latitude of positive 245.017 and then a departure of positive 44.335, and line P3, P4, a latitude of 52.225 positive, and the departure of negative 182.678. So, and the last line, which is line P4T, my corrected latitude is minus 421.290, and for the departure 144.574, negative 144.574. So when you do the summation of these, you should get a 0. For me, I did the summation, I got it as 0.001, so which is same as 0. Also the departure 0.001, which is same as 0. So now we shall calculate our adjusted coordinates. So I'll take the this point T we are given as 9372.98, and then if you want to calculate P1, you'll take 9372.98, and then I'll minus 27.599. So I'm getting as 9345.38. So I want to get the adjusted coordinate of P2. So I'll take my P1, which is this one, 9345.38, and then now I'll add 151.648. So for me, I'll just say answer plus 151.648. I'm getting as 97.03. Then for P3, I'll add 245.017. So answer plus 245.017. I'm getting it as 9742.05. Then the next one, I'll add this one, 52.225. So I'm getting as 94.27. And then the last one, I'll minus 421. So answer minus 421.290. I'm getting it as 9372.998. So you can see that point T1 here, the upper one that we are given, and the calculated one are the same. So this means that, so for the eastings, I'll take the eastings that were given in the question, that was 3854.28, the point T1, and then I'll add the corrected departure, which is 152.526. So my P1 will be 4006.81, and then I'll add plus, I'll take this one and then I'll add it by one, I'll add with the corrected departure of line P1, P2, which is 130.392. So I'm getting it as 4137.198. So for the next point I'll add 44.335. Answer plus 44.335. I'm getting it as 4181.53. The next one I'll minus 182.678. So minus 182.678. I'm getting it as 399.8.86. So when I want to get my T for these things, I'll minus 144.572 minus I'm getting it as 3854.28. So we can see that now we have already adjusted our coordinates, and our point, that is T, which had a nothing of 9372.98 and a string of 3854.28, we have it here. So that was the video about the tutorial. So if you have not yet subscribed, please subscribe my channel, and don't forget to press the notification button to get all my latest videos. Thank you very much.